Here is the combined summary. This research paper presents a novel drone-based curriculum designed to introduce high school students to fundamental programming concepts through hands-on learning with inexpensive helium balloon drones. The approach uses a custom web-based coding environment, enabling students to experiment with Python without extensive software setup. The curriculum covers basic programming skills and offers advanced projects, such as mobile app development for drone control and interdrone communication for flocking tasks. By integrating physical computing with algorithmic thinking, the authors aim to enhance student engagement, critical thinking, and problem-solving abilities. The paper highlights the importance of engaging educational experiences in computing education, which have been shown to have a positive impact on learning outcomes and examination performance. Physical computing devices have been correlated with increased student motivation when studying computer science. The author's research project explores the viability of using inexpensive helium balloon drones as a teaching tool for introducing computer science principles to high school students. The drone-based curriculum is designed to cater to students with varying levels of programming experience. For students with little prior programming knowledge, the curriculum introduces the basics of a Python-based API that enables interaction with drones. Advanced students are challenged with more complex projects, such as developing a mobile app for drone control. The curriculum will be delivered to high school students with an interest in computer science and robotics over a 1 to 2 week period. The author's engineered drones draw inspiration from blimps and feature a helium-filled balloon equipped with compact propellers and a microprocessor. The drones are expected to be programmed wirelessly in Python through a web-based interface. The paper outlines the structure of a drone-based curriculum, with the goal of assessing whether such a curriculum can serve as an effective method for teaching computer science principles to a diverse student population. The research paper presents a drone-based curriculum designed to introduce high school students to computer science principles through hands-on learning experiences. The curriculum utilizes inexpensive helium balloon drones and a custom web-based coding environment, focusing on fundamental Python programming skills and practical applications in robotics. Students engage in tasks such as basic drone control, mobile app development, and interdrone communication for complex flocking mechanics. The paper emphasizes the importance of creating a stimulating and supportive learning environment, encouraging students to develop creative solutions and address unexpected challenges. Future work involves implementing this curriculum in high school settings and evaluating its impact on student engagement, learning outcomes, and interest in STEM disciplines. The summary highlights key aspects of the curriculum, including the use of drones, the integration of Python programming, and the emphasis on practical applications, showcasing the innovative approach to computer science education.